Afternoon, HP test equipment fans. It's one final job on the 8660 frequency counter. I had to use an external reference. This Rigel AWG worked very well, but couldn't seem to get the original OXCO to adjust. And there's the information on it. Model PC, if I can get the phone to hold still, PCOXO-HP01. HP's number's 0960-0150. If you want to hate yourself, try to take that apart. Have quite a pile of things to throw, or a few choice naughty words saved up, because it's a pig to get apart. And the reason that can is that big is because there's a whole bunch of stuff in that can. It's not just a transistor and a crystal. Testing external 30 volt and 20 volt regulated supplies, 30.1, 20.1 volts DC. The pins on this puppy are: pin 1 is 20 volt DC, pin 2 is 30 volt DC, 3 is the RF out through an SMB quick disconnect, 4 is ground but not the case, and 5 is grounded also, and 6 is the oven light to the front panel of the HP unit. I screwed up real bad. This thing was running off frequency, and I took off these plugs in order to adjust coarse and fine frequency. Nothing in the manual about it. And I have the full HP manual. They don't cover this. Now, the fine adjustment is the upper left hole, and the coarse is the lower right. I falsely assumed that they were just simple PC board mounted trimmer capacitors. Terrible mistake, and I should have known better. This is high precision stuff. What's inside are 2-inch long, don't break them because they're $60 to replace them, inch long glass silver piston trimmers. And there were no bad solder connections. I theorized that the trimmer capacitors had oxidized and broken open. If that had been the case, it should have been way off frequency. So, make a dumb mistake now and then. No harm. But these trimmers are 22 turns. And when they're turned out, which disengages the piston, it appears to not do anything. And apparently somebody had turned these out. So the thing to do is turn them in very gently until the frequency starts changing. The coarse frequency, I don't know, 10, 15 hertz per turn. The fine is fractions of a cycle. So there's a trick to adjusting these. There's a good bit of hysteresis in it. Rotate them in or out a couple turns, you'll feel resistance to the screwdriver. Stop and turn the other direction, it'll be free. And land that adjustment in between, so the threads are not making tight contact. That should help stability a little bit. But I started this test at 2151. It's now 2220, and it is dead on 10. No, there, it made a liar out of me. You got to count just a bit low. I don't have the proper SMB cable, so I've got the scope probe and a piece of wire stuck in the socket. That's a poor way to do it. That's what I got. So the wire may have broken contact, but it's right on 10. Come back. 10 and 7 zeros. So the way to filter that out is to go to a 10-second interval. And this counter has a cool feature of giving statistical readouts. Inside I don't know, 10, 12, 15 transistors. I don't know, 10 resistors, several capacitors. And what you can't see, because it's hidden in there, is in between here is a flatted stem on an adjustable inductor. So that'll be part of the feedback circuit for the oscillator. Don't adjust that unless you got a real good reason. It's an HC6 package crystal inside. If it works, don't screw with it. It doesn't hurt to have some crystal air, because without an air, when the oven comes on, it may not be able to pull the crystal in. If the crystal supplied exactly on 10 megahertz cold, then the oven won't work or require excess capacitance to pull it back. So this one started off somewhere around 240 hertz high. As it warmed up, the temperature went down. Adjustment on the trimmers, screw them in to decrease the frequency. Gently. Metal screwdriver didn't make any difference. They're a little bit too tight for a plastic tool with a metal insert. They'll probably break it off. So I got to use metal screwdriver, but a little fine, tiny one. And this didn't seem to make any difference, but be sure when adjusting trimmers like this, never touch the shaft of the screwdriver to ground. I destroyed a transistor in the HP651 doing that. So that's about it. There are replacements these days for these things that you could put 100 of inside this can. But it's not a working plug-in module. They'd have to be put on a PC board with a connector and various things. So there's a way around it if this is just ruined. And I'm not going to try to take this apart and make a schematic. I'll stop video here and put in a couple of pictures of what's inside this.